Okay, today we're going to look at how to make a confidence interval for a proportion. And this situation I've got right here is I've got a sample of 47 students. This was actually my class from statistics last year. And of those 47, 29 of them were born in Virginia. And so I want to take this sample proportion and I want to try to figure out, based on this one little sample, what is the true percentage of all Hampton-Sydney students who were born in Virginia. So this proportion data right here, we can turn it into a single number. Right now it's 2. And the single number is called the sample proportion. And so the first question I ask is, what is the sample proportion? In other words, what is p hat? And so it's just the fraction. Remember, proportion, fraction, percentage, they all mean the same thing. So I want the percentage of students, or the proportion of students, or the fraction of students, and I don't actually care which version you give me as long as it's a right answer. So if you just give me the fraction 29 divided by 47, that's right. That's the percent or fraction of students that were born in Virginia. So fraction is fine. If you want to calculate a percentage, just go ahead and use a calculator and actually divide these two numbers. So I've got a calculator right here. So 29 divided by 47 equals 61.7%. So I can add that here, 61.7%. Or again, you can always write it as a decimal, 0.617. All of these are perfectly good answers. I'd accept any one of these. Okay, so that's the sample proportion. Now that isn't necessarily the true proportion of all Hampton-Sydney students, right? My class probably wasn't a perfect match for the true percentage. I might have had a few more or a few less than the true percentage of Hampton-Sydney students who were born in Virginia. But I can use my class, and in particular I can use the sample size to get an estimate of how much random error there might be. And that's what I ask you to do in number 2. I say, hopefully this class is reasonably representative. In other words, hopefully this class isn't a biased sample of Hampton-Sydney students. I can't think of any reason why it would be, so I'm going to go ahead and make a 95% confidence interval for the true population proportion. The formula for that, you can find it on the Common Inference formula sheet, this interactive formula sheet I have on my website. We're doing inference about proportions, and this is the confidence interval for proportions formula. It's the one with the plus and minus sign. It's one sample because I've got my one class of students. So I pull it up. I know what the p hat is. It's the fraction 29 out of 47. Z star, if I want a 95% confidence interval, I need the Z star for that. And this is one we use a lot. If you want to memorize any of these numbers, this is the one to memorize. It's 1.96. But if you don't have that memorized, here's how to find it. You just go to the t-distribution table, and the t-distribution table actually can do normal distribution Z star values too. You just have to know where to look. So I want a 95% confidence interval, so I look in the 95% confidence level column. And then I look down, but none of these degrees of freedom are right because I don't have a t-distribution. I have a z value from a normal distribution. So I scroll down all the way until the degrees of freedom get really, really big. And you'll notice when you get up to 500, the next row after that is z star, which is the normal distribution row. All of these other rows were different t-distributions, and if you notice, when the t-distribution degrees of freedom get really big, the numbers are almost the same as the z-star row, which is the normal distribution critical values. So if I want a 95% confidence interval and I'm using a normal distribution, then where those two line up, this is the right z-star for that. So you can use this to get confidence levels for normal distributions too, not just t-distributions. Okay, so there we go. So 1.96 is the right number. Like I said, it comes up so much you might just want to memorize that one. So now the only number I need is the n, and of course n is the sample size, which is the 47 students. I can just hit enter now, and there we go. That's my confidence interval right there. I've got my best guess was 41.7%, which is the sample proportion. We already knew that. And now I'm going to add or subtract this number 13.9%, which is the margin of error for the confidence interval. When you write your answer, I do prefer if you would actually calculate the two endpoints, if you would actually do that adding and subtracting. So let's do that right now. So I'm going to take my calculator and I'm going to take the 61.7 and I'm going to add and subtract these two numbers. So let's do the subtracting first. So 61.7% minus 13.9% drops me down to 47.8. And so when I write my confidence interval, I'll say I'm going from 47.8% to, and now let's calculate the upper bound. So let's clear this and do the 61.7 plus that 13.9% margin of error. And that's going to bring me up to 75.6. So to 75.6%. Okay, that's my confidence interval. I'm 95% sure that something's in there. What am I sure is in there? Well, it's the population proportion, right? I only knew the sample of my students, and it was 61% of my students that were from Virginia. But now I can be confident that the true population proportion, if I could actually interview every single Hampton City student and find out where they're from, where they were born, then I would be pretty sure that whatever number I'm going to get from that interview process would be between these two numbers. Okay, so I'm 95% sure that the true population parameter is in between these two percentages. Okay, so let me say that. So between 47.8 and 75.6% of all HSE students were born in Virginia. All right, I'm 95% confident that that's true. And that's pretty much the answer here, right? So 95% sure that the population proportion of all HSE students born in Virginia. That's what I'm sure is in the confidence interval. We usually just use a letter P for this. So we have P hat when it's the sample, and P without a hat when it's the population. Okay, now I've got this next bit here where I say, okay, now this sample size is actually not that big. I only had 18 students who were not born in Virginia. According to our textbook, that's big enough that you can use the confidence interval formula, and it's probably okay, but the confidence interval formula is not as robust as the hypothesis testing we did last time where we looked at the psychic powers stuff. And so you do have to be a little bit more careful when you use it. There is a way to make it a lot more robust. It's this one weird trick called the +4 method that actually is really easy to do, and so it's probably worth learning. So to do a +4 confidence interval, you take your data, which in my case is the 47 students, and you take all the students who were not born in Virginia, so there were 18 of those, and you think of those as like the quote-unquote failures, and then the other ones are the quote-unquote successes, and you basically add 2 fake successes and 2 fake failures to your data. So I'm adding 4 fake students to my data. So now I'm going to have 51 students. So my new P hat is going to be a fraction that's out of 51 students. And out of the 51 students, if I add 2 fake successes, that's going to be 31 out of 51 students that were born in Virginia for the +4 confidence interval. So this is including the fake data. And so now I go back to the formula and I'm going to change my numbers. Now it's 31 out of 51. And the z-star doesn't change. I still want a 95% confidence interval, but the sample size does change. I've added 4 fake pieces of data. So there we go. That's the new confidence interval. Changes my numbers slightly. Now I have a middle at 60.778%. And I've got a slightly smaller margin of error. So again, I'll use a calculator here to calculate the upper and lower bounds. To make my life a little bit easier, I'm just going to round 7/8 to just 0.8. 60.8 minus 13.4 is a lower bound of 47.4%. So I'll type that in. So I'm going from 47.4% to, and then on the upper bound, I need the calculator here, so let me pull both of those up so I can see the numbers. So I got 60.8 this time plus the 13.4% margin of error gives me 74.2. 74.2%. As you can see, this confidence interval is not that different from that one. It's actually very similar. The bottom bound, 47.4 versus 47.8, is hardly any different at all. The top bound is a little bit lower, right? It's 75.6 is a little bit lower here. +4 confidence intervals tend to be closer to the middle. They tend to tilt towards being around 50% or closer to 50% than the regular confidence interval. They're also more accurate. They're more trustworthy. So if you go into the trouble of making a +4 confidence interval, then that's the one you want to rely on. So this one, when I said I was 95% sure before, I'm even more 95% sure that this one is true, right? This one is a more robust interval. I can trust it a little bit more. Okay, finally, what is the margin of error for the +4 confidence interval? This is just a knowledge question. Do you know what the margin of error is? Whenever you do these calculations, you just have to know the number after the plus or minus. That's the margin of error. So you just copy that number. So 13.4% is the margin of error for the +4 confidence interval. Great. Okay, that's it. That answers all of these questions. Keep in mind that the +4 technique is something you can always do, but if your sample size is really, really big, like up in the thousands, it probably won't make any difference at all. It's really useful when you have small sample sizes. It makes these confidence intervals very robust, even with very small sample sizes. It's actually probably one of the most robust of all the statistical techniques that we're going to do. Let me know if you have any questions, and I'll talk to you guys later.